This presentation is being recorded and you are currently in listen-only mode. Now, without any further delay, I'd like to turn today's meeting over to our presenter, Esteban Garcia. Esteban, you now have the floor.
Thank you, Jana.
Thanks, Esteban.
All right, so now I'm starting to should be presenting now. Okay, well, thanks everyone for joining us this afternoon. My name is Esteban Garcia. I'm a solutions architect and ALM consultant at AgileThought. We're a software consulting company based in Florida. We do a lot of ALM work. We're a Microsoft partner, Microsoft Gold partner in application lifecycle management and application development. I'm a Microsoft ALM MVP and Visual Studio ALM Ranger. Today we're going to be talking about continuous integration with TFS. We're going to be showing you how TFS can help you and your team create automated builds, automated tests, and deploy your applications with using TFS and Visual Studio 2012. Here's a little bit about our company. So what is continuous integration? I'm sure you've been approached by someone maybe at your work, or you've read about continuous integration, and maybe you've thought, wow, that sounds great, but it must be really difficult to be able to implement it. So what does it take to be able to implement continuous integration? And before that, what does it even mean? In a world where things are becoming more agile every day, people are asking us to do more and more every day. So how do we take advantage of the tools? How do we take advantage of TFS and Visual Studio to be able to implement CI, or continuous integration? So there are some key factors that you need to take advantage of whenever you start thinking about continuous integration. First of all, you need to think about integrating your code frequently. If you have a big team working on different features and everyone has a different branch, you want to make sure that that code gets checked in or integrated together as often as possible. Even if you don't have multiple branches, if you have many people working on your project at the same time, you don't want to wait a week or 2 weeks before you check your code in. You want to make sure that you're checking your code in, and not only that, but you're also getting latest based on what people have checked in, so you can integrate your code. You want to make sure that your continuous integration builds are automated. I've been in places where they wait for the last person out of the door, make sure you hit the button so you build, or we're going to do a scheduled build at noon every day. And those work sometimes, but really when you're thinking about continuous integration, you want to get that feedback right away. So you want to know that anytime you check your code in, the build is being kicked off automatically. You want to make sure that your continuous integration build is not just verifying that your code compiles, but you're also running unit tests so that you can confirm that your code is still working the way it was supposed to. Unit tests can tell you a lot about your code, and it's not difficult to get started with them and start implementing them, especially with Visual Studio 2012 that allows you to use NUnit, MS-Test, XUnit, and many other testing frameworks right out of the box. So your unit testing becomes a much more trivial process than before. Continuous integration helps you and your team get to the finish line a lot faster. Sometimes you might think, well, now if we start building our code every day and we find problems, now that's going to slow us down. But think about all the time that's going to save you down the road when you're trying to deploy your application, and just when you're ready to deploy, you find a lot of issues. So it's better to catch them up front. And obviously, CI gives you feedback, lots of feedback and rapid feedback, and that is the main reason why you want to make it automated and integrate frequently. So what's involved making this happen? First, you need a single source repository. You can't have all these different places where you store your source code. TFS, or Team Foundation Server, is a perfect place for that. It's one centralized repository where everyone can share code from there, get latest, check in, and really have everything together. Next, once you have your code in a single source repository, you want to automate your build. Again, TFS gives you a way to automate your build and integrates really, really well with all the other pieces such as version control and work item tracking. You want to add some unit tests to your code, and you want to make sure that those are added to the build. As I mentioned earlier, you want to make sure that you're committing as often as you can. Don't check in broken code, but once you have something that's working, go ahead and commit it and get it playing along with all the other code that's in the system. Always keep your CI builds fast. Sometimes people run into issues where you want to do too much with your continuous integration builds. And that's what nightly builds are for. That's what scheduled builds are for. If you have a build that's going to take an hour to run the build and run every single test case out there and deploy it to 5 different places, then those are the wrong type of activities to put into a continuous integration build. You want to keep it fast, because if you're working with a team with 5 people, 10 people, 100 people, you don't want everyone waiting for your build to complete before they can check in. So keep it really fast. Always make the build outputs accessible to everyone. If there are any issues, you want to make sure that someone has easy access to be able to debug the problem. Or if the build's completely successful, it'd be great if your QA team or your development team can take those files and deploy them to a test server to start testing. And whether your builds pass or fail, those results should be visible to everyone. With so many builds running, you're bound to make some mistakes. You're bound to have some broken builds, but the fact that they're visible helps everyone understand what happened and learn from your mistakes, and also learn from the successes. So let's talk about what TFS and Visual Studio bring to the table along those lines. So a lot of people use Team Foundation Server mainly for version control. Some people use it for work item tracking, but there's a lot more to it. So what is Team Foundation Server? Team Foundation Server is a catalyst for all these different pieces to be able to work together. So you have project management. You start you want to create a new project and manage the timeline and manage the process of delivering that software. You have requirements management. You have something called work item tracking that allows you to keep track of requirements or user stories and break those into tasks. And imagine being able to take those tasks and be able to associate those tasks to pieces of code that you checked in. So when you're checking the code in, you can associate those tasks to your version control change sets. Once that's checked in, you can the build automation piece of TFS can take over and take all those version control files that you checked in and compile them, run test cases against them, and then create even more associations between the build, all the change sets that went into a build, and all the work items that went into a build. So now you have a nice build report that says, well, this is what I'm delivering to you to production or to QA. Then your testers can take advantage of Microsoft Test Manager and through test case management associate test specific builds and then associate any bugs against your requirements or user stories. So that gives you full traceability across the entire software development lifecycle. Obviously today we're going to be focusing on build automation. So let me show you how that part works inside of Team Foundation Server. So the build system in TFS, starting with TFS 2010 and beyond, has been looks like this. You have your Team Foundation application tier, and within there you have a team project collection. A team project collection is made up of one or more team projects. Each team project collection has a build controller associated to it. You can have more than one controller, but at least one. And the build controller is almost like a traffic cop. So the collection tells the build controller whenever it needs something built. So the collection keeps track of whether there's any scheduled builds that need to execute, or just you just check some code in and you need to execute it, or maybe someone just manually queued a build. So once the collection is aware of this, it tells the controller, hey controller, go and build this for me. Then the controller has one or more agents, ideally more than one agent. And those could be on the same server or could be across many different servers. And the agents are the ones that are doing the heavy lifting. Those are the ones that are doing all the heavy work of compiling and running test cases, and any other thing that you want your build to do. The controllers is sending messages to the agents to do work. The agents are sending messages back to the controller, giving them some feedback and progress of what's happening right now. The controller keeps track of those logs, and then once the build completes, it'll send all the information back to TFS server, where that information will be stored for you to be able to do any reporting or just keep track of any builds and build results. You can associate your agents with different tags. So you can say this one agent is set up to do MVC builds, this other agent set up to do any SharePoint builds, this other agent is set up to do some WPF, and maybe this agent over here is set up to do some Windows 8 applications. And build agent number 5 is going to do some C++ builds. So you can tag builds with different, you can categorize them so that the controller, when the controller is trying to find a build agent to run the build for it, then it's going to pick the right controller to do the work. So let me switch over to my virtual machine so I can show you what that looks like. So here in my VM, I'm showing you Foundation Server Administration Console. Underneath that, I pointed to the build configuration, and with here I have a controller and one agent. Obviously, I could set up multiple agents across many machines. Right now, I just have one agent on my VM. Let me show you some of the properties that you have on the controller and the agents. So click on the controller properties. I can see the controller name, the machine name where this controller is running. And this is very important, the version control path for custom assemblies. So one thing that you can do with TFS is that you can create your own activities, or you can you can go to Coplex and download a community build activities. Third parties have different either build activities or just assemblies that are needed for you to be able to run the build. In this case, we're importing the XUnit runner to be able to run XUnit test cases. But you can specify somewhere in your source control where you're going to deploy all the assemblies that you build. System is now going to bring into its memory space to be available whenever a build is running. So that's something really important, especially once you get into the more advanced concepts. Number of agents that you may have, and whether the control is enabled. So here you can associate more controllers or more agents to your collection. Next, let's take a look at the agent. And as I mentioned earlier, the agent is the one doing the work, doing all the compiling and testing. So here you tell the agent what controller it's associated with, what machine it's running on. This could be running on a different machine, and working directory. Where is it going to do a get latest to whenever you're going to run a build? And here's where you can add tags. So you can take this agent and say, well, this agent is set up to do maybe some C++, set up to do some Windows 8, for example. So I can just keep adding new tags here, and so let's add C++ again, or maybe this agent is also can do maybe some MVC development, MVC builds. So that's how you add tags, and those tags are available across your entire system. For now, I'm going to check these since I'm not. I don't want to set this up right now for this one. So that's the build itself. It's controllers, agents, and TFS. That's pretty much it. So let's switch back to PowerPoint. So how do we start? By the way, if anyone has any questions at any point, feel free to just type in a question on the type in a message, and I'll get to the questions throughout the presentation. Okay, so how do we get started? So let's say that you have an MVC application and you wish that you could just start doing some build automation for it. You don't want to just keep doing F5 or Ctrl-Shift-B every time and just copy and paste those out to the server. and you don't want to just have a dedicated machine in the corner that no one can touch. That's your build machine, right? And it's always a manual process. So how do we even get started? So the scenario is that you're using Visual Studio 2012 and you're using TFS 2012, and currently you're just using TFS as a version control system. So we're going to start by creating an automated build. I'll show you how to do that. Then we're going to add some test cases to that build. Well, first we need to add test cases to your solution and then add them to the build and show you how those test cases will be executed automatically. We'll make sure we keep it fast. That's you always keep that in mind when you're setting up a continuous integration build. And then finally we'll add a check-in trigger. We want to make sure that our CI build gets kicked off automatically every time someone checks in. So let's get started. Then switch back to my VM. And I am now in Solution Explorer. So I have this web application. It's an MVC application that it does this. It's just a dashboard application for a cable company that allows you to keep track of any customers and tickets and things like that. So let's go back to Visual Studio. The first thing I want to do, once I have my solution here and I know it builds correctly, so I'm just rebuilding just to make sure everything is good and it builds locally. Let's give it a second since sometimes my VM runs a little slow, but here it goes. Alright, so my build completed successfully, and I'm going to switch over to Team Explorer. Under Team Explorer, first thing you see when you get to Team Explorer is everything that you can do in TFS. I'm going to click on the Build section, and that navigates me to the Build tab. Here I can create as many build definitions as you'd like. So I'm going to start by clicking on this link at the top that says New Build Definition. And that brings up the build editor. And let me give you a little more space here so you can see everything. And in my build editor, I'm going to start by giving my build a name. So let's call this our CI build. And you can give it a description if you'd like. So let's just CI build. And then you're able to either set it up as enabled, paused, or disabled. Usually you would create as enabled, but if you ever want to make any changes to your build and you don't want any builds to be queued up while you're making changes, you can pause it, and any new builds will just be queued until this is ready to be until you enable it again. Next, we're going to set a trigger. For now, we're going to keep it manual, but later on, we're going to move into a continuous integration. Manual means that you're going to always kick off a build manually yourself. You're going to right-click on the build and you're going to kick it off. Continuous integration means that every time someone checks in files into the workspace that the build definition is configured for, the build will automatically run. If your CI builds take too long to run, remember we want to keep it fast, but if for some reason you can't keep your builds fast enough, or you don't have enough build agents to keep up with more CI build requests, or your team is just too large, you can create something called a rolling build. A rolling build allows you to still keep checking in, and then instead of kicking off a brand new build for every single check-in, it's going to accumulate all those check-ins while the build is running, and once a specific build completes, then it's going to roll up all the check-ins and then run a build for all those together. The next option is gated check-in. Gated check-in allows you to do what TFS calls a private build. A private build means that whenever you're ready to check in, TFS is going to take your files and is going to shelve them in TFS. And then it's going to run the build against those shelved files. Only if that private build completes successfully will it then take those shelved files and integrate them with version control, and then run the build again, run a regular CI build against those files if you have a CI build set up as well. And then finally, you can schedule a build. You can. This is great for nightly builds or daily builds where you want to make sure that every day at 3 in the morning, at 11 p.m. or at 5 p.m. or noon, whenever it works for your team, you have a build that runs. and that's usually where I put a lot of my more time-consuming tasks. You know, if you have, for example, if you have an Azure app and you want to deploy it, well, you don't want to deploy it every time you do a CI build, or not even just an Azure app, just any web app or any app. You don't want to keep deploying 1,000 times a day. So maybe just you want to deploy once a day at 2 in the morning, and that's where you would set up a scheduled build. So we're going to start with manual. Next thing we're going to do is set the source settings. The source settings allows us to set up which files what files do we want to create for what folder do we want to look at whenever we do a get later, so whenever a build starts. So where are the files coming from? You can this looks directly at your source control. So if you want to go a little bit farther down, instead of going down at all the way at your root, you only want to build your dev. Anything under the dev branch, you can do that, or your main branch, or one of your releases. So you can do that. So depending on where you want to point your files. The files that I'm building right now, these are all coming from my dev branch. If I look at my solution, it's in my dev branch and then the solution file. So maybe I'll create my Active Directory as Fabric and Fiverr dev, and then I can remove this cloak folder here. And then what that means is every time my build is going to kick off, it's going to do a get latest of my dev branch, and it's going to run a build against that and nothing else. Later on, when we create a CI trigger, then this dictates what folder our CI build looks at before it knows whether a build should run when someone checks something in. So now we're going to take a look at the build defaults. Your collection could have more than one controller, so this allows you to pick which controller you're going to ask to run your build. And then remember earlier I mentioned about you want to make sure that your build outputs are available to everyone. So I'm gonna want to make sure that my build outputs are copied out to a share that everyone has access to. So this is my share that I'm going to be using. You can opt out of this, and you can just say, well, I don't want to copy outputs, but I'd like to make a habit of copying all my outputs so that they're available to everyone. Next, we're going to the process section, and this is the probably the most important part of the build. This is where you tell it what is it building and what are the options that you're going to be using whenever you run your build. First thing is the template. The template is it's a Windows workflow file that dictates what the activities and the sequence that the build should follow whenever it's running a build. I'll show you what that file looks like in a little bit, but it's a one big XAML file that dictates the sequence. Next is the items that you're going to build. So I want to build a solution. Since I have this solution open in Visual Studio, Visual Studio was smart enough to tell it what solution it should build. If I didn't have a solution open in Visual Studio right now, this would be blank, and I would have to browse through my version control and find the solution that I want to build. You can build one or more solutions. You can actually build a project. You don't have to build a solution. If you have a specific project file that you want to build, you can just add that. So you can add as many projects or solutions as you want, and you can set the order by moving them up or down. You can also set the configuration that you want to build, whether you want to do a debug or any platform, any CPU or a debug build. You can set that up. If you leave this blank, it's going to just use the default configuration that you have set up in your solution. Next, there's an automated test. This allows you to specify whether it should run automated tests or not. By default, it will run automated tests if you have any. And you can set other options such as the build number format. If you don't want the build number to look this way, you can just change it to something else. Whether you want just your build number to have maybe the team project name or the revision or things like that. So this is how the build reports back to you. Then next option is just like whenever we're building locally, we can do a clean solution and then build, or a full rebuild. Or if you just want to build. So this dictates whether TFS is going to recompile every single application in your solution, or if it's going to recompile only the ones that changed. I usually like to do a completely clean build, but in some cases you may not want to do that. You can set the verbosity of the information that you get back on your build, set code analysis, and then some additional items. We'll touch on those in a bit. So the last thing that you want to look at when you're setting up a build is the retention policy. Depending how much space you have in your server, you may want to change this. So by default, TFS is going to keep the 10 latest succeeded, partially succeeded, that failed. Partially succeeded means that it was able to compile the application, but then something went wrong afterwards. Maybe a test case failed, or you tried to deploy and that failed. So anytime your application compiles, but then something goes wrong after, you have a partially succeeded build. So if you say, well, I don't have enough space, or I have so many builds and my drive is getting full, you can just come here and just change the build to say, well, maybe I should just keep the last 5 instead of the last 10. And if something fails, well, maybe this one, let's keep 7 because we want to keep more failed. And you can even keep, you can even specify what should be deleted once you reach this number. So by default, it's going to delete everything from the machine, but you can say, well, maybe keep my symbols and just delete everything else, or just keep my test results by delete my details, my drop. So you have quite a bit of control of what you can do here. So let's go back and save this and close my build. So now that I have that done, I can go to my Team Explorer and I can right-click on my CI build. I'm going to queue the new build. And from here I can queue it. And that's going to kick it off. And I can open this up. I can see it running. Also, if you take a look at the build from Team Explorer, you can see it as well. So what's happening here is that the build, as I mentioned earlier, it's the TFS contacted the build controller and said, hey, I need something built. The build controller found an available agent. In my case, I only have one agent. So it found that agent, and the agent is now executing this build. All done. The build completed successfully, as you can see here. One second, my VM seems to be not responding with my mouse here. Okay, so let's take a look at what information this gives us. So I can take a look at my my build information. I can also go look at the log file, and this gives me a lot more details about the steps that were taken. If I click on the MS build log file, that gives me a text file that gives me with all the information about what exactly happened inside of the build. If you're interested in that, it's usually really good when you're trying to debug some your builds. So great. So now we have a fully working automated build. We're just compiling. We're not doing much with that. So let's add some test cases or projects. So I want to make sure that not only am I compiling the build, but I'm also I'm also verifying that my build completes successfully. So let's open up Solution Explorer, and I'm going to open up. I'm going to add some test cases to my build, to my solution. So I'm going to right-click Solution, add existing project, and I know my files are here, so let me copy that out. And I have some a test case project that I already had set up from before to save a little bit of time. So this test case project has some interesting information for you, so let me show you that. So test case project is made up of this specific one. I have 3 different files here, and the mix of test cases is what's interesting. So I have some MS tests going on here. I have some XUnit test cases here and here. So I just wanted to show you how out of the box TFS supports multiple test case frameworks. Visual Studio 2012 supports them, and then you're able to add some helper files to TFS so it knows how to do them. So once I've added this test case files to this test case project to my solution, I'm going to test my my test to make sure everything works locally before I add it to my build. So I have my test explorer. I'm going to run all. So I have 5 test cases, or 6 test cases that completed successfully. Once that's done, I'm going to add them to my build. And to do that, I'm going to check them in. Once those are checked in, I'm going to go back to my build section. And I haven't set up my automated builds yet, so I'm going to kick off this build.
Esteban?
Yes?
You have a question whenever you are ready.
This is actually a good time while we wait for the build to complete.
Okay. This is from Farhan, and he says, do we have any information on the licensing for TFS 2012? Currently, we are using it with one MSDN license in dev environment. Can we attach more users to this build environment, or do we need separate licenses for each? Is there any idea how licensing will work for production?
Yes, so I'll preface this with saying that I'm not a licensing expert, but I can tell you that you can use TFS. So with your MSDN license, you have a license to be able to use TFS in production, right? But to be able to, for each person that connects to TFS needs to have a client access license. A client access license, you get one for every MSDN license, but if you don't want to purchase an MSDN license for every user, you can purchase a client access license separately that will allow you to connect to TFS itself. All right, so, and if you have any follow-up, let me know, but let's move on to showing you what the build looks like now, the build results. So I just completed my second build, and compared to the previous build, now we get this other section that shows us the test, how many test runs were completed. So one test run was completed, 100% pass rate. If I click on this file, let's see if it comes back this time. There it goes. Sometimes I said my VM goes a little slow, so that's why we get that message. So I can see what test case passed. So just like I could see them right here in Test Explorer, I can see a list of test cases that passed. I can see them. I can click on this link, and it will pull up the list of test cases that passed. If I have any test cases that failed, it will show me that as well. I don't have any code coverage results at the moment. That'll be nice as well. So code coverage allows you to not only see how many test cases you have, but how much of your code is being covered, right? So just because you have 100 test cases or just some arbitrary number doesn't mean that you have a good amount of test cases. So by adding code coverage to your results, you can actually get some information about that, and then that allows TFS also to keep track of, to give you some metrics on that. So maybe you take a look at your build today, and you may be at a 40% code coverage, and your goal as a team is to be at 70%. By turning that feature on, you can keep track of that as a team. If I double click on each one of these items, I can get more information about the test case that passed. In this case, all these test cases passed, so there's not a lot of debugging that we're going to be doing. But if we have a failing test case, obviously we'll need to get some information. Once I have that, so let's go ahead and add our code coverage. So I'm going to go into my CI build, edit build definition, go to process. And under automated tests, I can go to my test source, and under the run settings, type of run settings, instead of picking just default, I can say I can enable code coverage. So I can say code coverage enabled. And there's other options depending what you do, whether you're doing ASP.NET or if you want to specify your own code coverage options. So once I have that, I'm just going to save that, and let's kick off the build again. Let's take a look at it. It should be done. Let's do it quickly. Before it took about 37 seconds, so it should be almost done. While that runs, let's go back to Solutions Explorer and talk about what else can be done here. So if we're in, let's say we want to show how our test cases, what will happen if you have a broken test case, right? So first, let's switch our build to be a true continuous integration build. So let me go edit my continuous integration build, the trigger, and instead of manual, I'm going to set continuous integration here. Save this. So now that means that every time I make any changes to my solution and I check in, the build will automatically kick off. Great, and let's go back to solution and let's add some test cases. I have a test case here that I know will fail, so I'm going to add it and show you what will happen if you have a broken test case. So here's my test case, and let's go ahead and check this in. And if we go to our builds section, you can see that even though I didn't kick it off, a new build just kicked off a second ago. It just started. The previous one completed earlier, and this one just got kicked off automatically. So this, so while this runs, let's go take a look at the build that ran before. But this one you can see that it was kicked off by my build, and if you can see while I'm hovering over, you can see here that it was requested by me, and it was a continuous integration build. So let's look at the previous build, and when we ran the previous build, we had turned on our code coverage. So now we have an extra option here that tells us that we've instrumented 3 binaries, and we have 12% code coverage. So even though I have a 100% pass rate, a 12% code coverage is not that great. Well, at least 65% of my test case assembly is covered, but that's not impressive since that's our test case assembly, and our web assembly is 8%, so that's pretty bad. So let's go take a look at the code coverage results. And here they are. And from here, I can start drilling down the results, and I can see that 100% of my data access layer hasn't been covered. So obviously, I need to write some test cases that touches my data access layer, and my web application, my MVC app, I'm only covering 8%, so 91% is not covered. And I can start drilling down and see where are my biggest problems. Or let's take a look at the ones that we have the best code coverage at. So we have 16% code coverage in our controllers, Go a little farther, and this one's actually home control 100% covered. So great, let's go take a look at that one. And so I can double click here, and it'll actually show me code, and it'll color code my code, showing me how much of it has been covered. Oh, okay, so this is the problem with running VM sometimes. So let's kick off Visual Studio again. Well, that kicks off. Let's that starts again, which should be coming up in a second. Let's go back to the slides, and we can keep talking about what the next section is. Right. So what's next? So we have a build. We're at the point where the build compiles correctly, and we're running some test cases. We are running some metrics. We're doing some code coverage. So what else can we be doing? We can add code analysis. So code analysis means like FX cop, right? So if you have a set of rules that you want to check your code against every time someone checks in and run the build, you can turn on code analysis. You can add more metrics. You can create alerts. So maybe every time your build fails, you want your team to be notified. And maybe you want to deploy your application as well. So let me show you how to do some of those things. So let's switch back to my VM, and looks like we're back up and running. Let's open up our solution. Okay, here's our solution again, and let's take a look at Team Explorer. We should have a partially succeeded build by now. So look to builds, and remember the last build that we added, we had a broken test case. So we have a CI build. Before, all our builds were green, everything was passing, but our last one had there's an issue, so it partially succeeded. If I open this up, it tells me it partially succeeded. My solution still compiled successfully, but I have only 85% pass rate in my test cases. So if I look at my test cases and open this up, it tells me that 6 out of my 7 test cases passed, so there's 1 failed test case. So I can open this up. And it shows me the test case that failed. If I double click on the test case, it will give me more information about why it failed. So this is plenty of information for me to be able to go back and debug the error. So it gives me line numbers. I can open up a file and take a look at exactly where it failed, and that allows me to go back and debug my test cases and hopefully have a working build again. Obviously, you don't want to stay with a partially succeeded build for too long. So see how I clicked on that link, and it took me directly to a line of code where my issue is. So from here I can start and debugging and fixing my build. So the next thing we talked about is adding some more metrics, right? So what if we wanted to add some code analysis? So let's go and edit our build. And let's go to process, and I want to turn on FX cop. And there's a couple of ways to do it. I can either go to my my project, so I can go to my web project and go to properties. And I can go to the code analysis tab, And at this point, I can turn on code analysis or I can enable it, and then I can apply different sets of rules. I can even create my own custom rules if you want to have it check for specific naming conventions, coding standards. Make sure that you have maybe a header in some files, or you want to just apply all the Microsoft rules. So I can turn this on here, and then I can go to my build definition, and then perform code analysis. I can just leave it as configured. Right now, my web project is not set up to enable code analysis, so as configured means that it's not going to do any code analysis. Or I can tell you know what, no matter what people configure the project as, I always want to run code analysis when we're running automated builds. So that makes sure that we're running, that we're actually checking for this, and we're making sure that we have clean builds all the time. So let's go ahead and queue this new build. And obviously this build will also be set up as partially succeeded because I didn't go back and fix my build to not partially succeed. While this runs, let me show you how to set up alerts. So when the build fails or when a build succeeds, maybe you want to get an email, or you want the whole team to get an email about the status of the build. To do that, we go back to the Team Explorer home, and under settings, I can go to project alerts, and that will pull up Team Foundation Server Web Access. And it'll take me to the alert section where I can configure these alerts, and you can either configure your own alerts or you can configure alerts for the whole team. It's just taking a little while to come up. So while we wait on this one to come up, let's go back and take a look at the build results for the last build that we ran. So this build results doesn't look as clean as the one that we just ran, because now we have all these warnings, and these are all these are all warnings based on the code analysis that we enabled, right? So there's some design warnings up here. There's some naming convention warnings down there. So there's quite a few warnings there, and they're all related to my FX crop rule that I am now checking for my build. So this is great information. I can go take a look at my based on this information. I can have my team go back and fix these warnings. It gives you the warning number. From here you can go and just bring those warning numbers and get specific information about them. So let's, with that, let's go to my alerts. Now that this is on. So there's two different alerts that you have. You can either set up your own alerts. So anytime any build completes, email me, or maybe anytime my own build completes, email me. So you can set those up, or you can say, well, I don't want to be the only one that gets these alerts. I want to let's go to the advanced alert management page, and that allows me to set build alerts for my whole team, not just myself. Here, this is my team alerts, and I can create different alerts for my team. So I can create a new build alert. So anytime a build fails, with a status of failed, or maybe a status, and I can add some clauses. So say it's failed or status equals partially succeeded, and I can join these two. So now for my team project, whether I get a failed or a partially succeeded, I want you to email the whole team. So now I just created a team alert. So now everyone's going to be notified. So it's a few different ways for you to be aware of what's happening within your build. Here, obviously, people can take a look at the build report, build status here. If I go back to build, and I just double click build, it'll take me to, I can see everything that's happened today, on the past, or any time, either across one build or any one of my builds. So these are all the builds that have happened in my project. So you can keep track of things this way. Another way that TFS allows you to look at status is through reports. So Team Foundation Server integrates with reporting services. So reporting services is able to pull data out of TFS, and there are a few canned reports that come out of with TFS. One of them is the build summary report. It gives you information about all the builds that have executed. So there's a couple that I ran today. Let's see if there's the new ones show up. So this gives you information about the build that you ran, what type of configuration you ran, and also information about your test cases, how many test cases passed, how many failed, and your code coverage. So this is a build report for what we've done today. So we had some partially succeeded, some succeeded, and what's really interesting is it tells us the passing rate for test cases and code coverage. So with this information, you have a lot of data about what's happening in your project, whether how much code is changing, how are we doing with your test cases. So from a project management perspective, this is a great way to look at things. You can also take a look at your build success over time. That just gives you per day how your tests are doing. So this is a more high-level report than the build summary, but you can get quite a bit of information especially if you have a lot of builds. Once you have many days to compare. Next thing I want to show you is how to customize your build a little bit. So what I've shown you so far is the ability to use the out-of-the-box build definition. So there's a build template that comes with TFS. If I go to edit build definition, when we're setting up the process, there's a default template. But what if you want to have different activities happen during your build? Maybe you want to FTP a file somewhere, or you want to replace some files, or you want to send messages, or how do we do that? So let me show you that part. So if I have a default template, I want to edit my own template. So to do that, I can click on New, and then instead I'm going to have it just copy an existing XAML file. So I'm going to copy the default template, and I'm going to call this a demo process template. And click OK. So all that's going to do is just going to copy the default template that comes out of the box, and then I'm going to have my own template that I'll be able to change and do with it as I please.
Esteban?
Yes.
You have another question here. Is there any type of reporting capability on TFS Cloud if we are not hosting TFS in-house?
So there's no SSRS reporting tied to the TFS service. What they've released just a week or two ago are some charts. So you'll be able to start seeing some charting with TFS on the cloud. I don't believe that any of those charts cover builds, but currently they cover some of the project management features. But I would expect that there are going to be some build related charts coming in the future. But yeah, there's no SSRS tied to TFS servers at the moment. All right, so now that I have my demo process template created and my drop-down list changed to use that demo process template, I can go back to Source Control Explorer, and under my my team project and under Build Process Templates folder, now I have a new demo process template XAML file. I'm going to get latest out of that and open it, and it's a Windows Workflow Foundation sequence diagram, and this is where you're able to make some changes to the way your build runs. And I'm thinking right now that when I set up my VM, I should have given it a little bit more memory. I think I'm running out of memory here, so here it comes. That's why things are a little slower, well, a lot slower than you normally see them. So anyway, so I have my XAML file that's opening up. It's coming out right now, just waiting to load it. And as I mentioned earlier, this the build template includes the full sequence of what happens from the moment that that you request the build to execute, everything that the controller does, and all the activities that the controller tells the agent to do. So it will include things such as labeling your files, getting latest, compiling, running test cases, deploying, and a bunch of other things. So let me go ahead and collapse this, because at first look it can be a little bit overwhelming, but it's really not that complicated. This shows you all the different options. First, you're going to update where the files, where are we going to get the files from. Then under Run on Agent, that's the part that the controller tells the agent, hey, go run these things for me, such as compiling and running test cases. And then at the end, we do check-ins if we need to. If I start digging through here, you can see that this is, this goes pretty far down, and I can where the actual compilation happens is all the way down here. Compile and test. So this is where actually MS Build gets called. So it's all the way down the sequence. You're normally not gonna have to go all the way down to the top to do that, but that's just so you know where things are. So let's say that I'm just gonna add some very simple customizations to my build template just because of time constraints. But let's say that we want to we have a process, and at the beginning of the build I want to see a message. So to do that, I can go to the toolbox, and this gives me all the different activities that are available to you from the Windows workflow side of things. So here's my Team Foundation build activities, and maybe I want to pass in a message. So let's go build. So write build message. I'm going to take this activity and I'm going to drag it into my sequence. And right at the beginning, before we do right after we get the build, let's just drop it in here. We're going to write the build message, and then we're going to go to properties, and this is the message that I'm going to write. Okay, then this is just a string in my case. Starting the build. Okay, so I have my message here, and let's give it a display name. So starting message. And then let's do the same thing, but at the bottom, once we're done, let's write another build message saying that we are completing the build. And this actually needs to be between quotes because it's a string. Now I'm done with that. I'm going to save my template changes, and I'm going to go to Source Control Explorer and check this in. Anytime you make changes to your template, you have to check them back into Source Control. Actually, one more thing I need to do before I do that. When I go to my messages, I'm going to give it importance. Right now it's just a normal importance. I want to give it a high importance, which will make it show up even though I'm not doing a even though my diagnostics is not set up to really high level. So I want this message to always show up. Great. So if you have some samples of activities that I've done before, I had a WPF application where we wanted to create an image with a version number that would be part of the splash screen, for example. So part of the build, I would find out what the version number was, and then I would embed that version number into the splash screen image, for example. Or let's say that you want to FTP files once you're done compiling, or if you want to, one team had they monitored Twitter for any messages from the build server. So we just sent a tweet every time the build completed or build started. So there's a few different things that you can do. You have the full power of .NET once you're in here. So your activities can be as sophisticated as you need them to be. So let's go back to source control and let's check this in. Messages. And we're going to check this in. And let's kick off our build again. So now that our CI build is using our demo process template. I'm going to go to Team Explorer, go to build, and let's kick this off. And this just got started. And we should see our message coming through in a second. Yeah, so here's my message that I just put in, starting the build for demo. So that's, even though I put it in just now, it looks like it's part of the regular build stuff that we've seen so far. So it's fully integrated. It doesn't look like it's out of place. If you had activity happening here, it would just get called, and depending what type of message you send back to TFS will acknowledge that the activity happened. But now, wouldn't it be great if I can tell it what message it should use instead of just coding a message in there? So let me show you how to do that. Okay, so let's go back to our sample. And I'm going to add a new argument. So anytime you, when we're looking at our CI build and we're setting values here, these are just arguments. This is very very flexible in the sense that it lets you do whatever you need your build to do. So you can take the default build and just really do whatever you need them to do. So let's add a message. Let's call it welcome. So starting message. And it's a string, and let's also create another argument called ending message, and it's also a string. And by default, let's give it a default value of we're going to give it a default value of starting message and ending message, just so that it'll work even if people don't enter anything. So starting message, let's call it default. And let's give this guy a message of default ending message. And save this. And just like before, we're going to check this in. Now I'm going back to my CI build. I'm going to refresh since I just added some arguments. I'm going to refresh that. Now my starting message and ending message show up under this miscellaneous tab with my default messages. Obviously I can override this, so I'm going to override my starting message. So let's call this override starting message and save this. And once I have that, I can kick off my build again. Go to builds, queue that build, and then we should see that coming in with our override message. Oh, actually, it won't, because even though I set my my arguments here, I never replaced them up here. So let's do that. So instead, let's go back to our starting message activity, and instead of using a hard-coded message, let's tell it that it should use the argument called starting message. So let's replace that with that, and we get full intelligence right here. So starting message for this one, and we're going to go to our all the way to the end, and our end build message is going to use our ending message argument. So now I can save this and check it in. And we go to our builds. And I'm actually going to stop the build that's running right now so we can see our new message. Go to queue a new build again. So now our new build is going to show our custom message that we set up. Now that's great, but if we go back to, and I'll show you that in a second, I just don't want to take too much time from, we'll have a little bit of time. So this is great, but now every single one of my new arguments is going to show up under this miscellaneous tab, and these are not nice names like all this stuff up here. And as if you notice, as I click through all the arguments that are up here, these arguments get this nice help section. These ones don't. This is just blank, and it just tells me the argument name and nothing else. So I'm going to show you how to make this a little bit more user-friendly. So let's go here, and let's copy this. So if I go to the metadata section of my arguments, and I can add a new argument here under metadata, and the parameter name was starting message, and I'm going to have a new display name, and it's going to be starting message with a space between it just to read a little better. And the category, instead of it being miscellaneous, I'm going to call it demo category. And here I can give it a description. And then I'm going to set this so that it's you can set it anytime anytime you're editing or you're queuing the build. So I set my starting message, and I'm also going to set my ending message. And let's call this it's also under demo category. Yeah. And we're also going to make it so it always appears. I'm going to click OK and save this and go back to Source Control Explorer. I'm going to check in my pending changes, and then we're going to before I kick off a new build, let me show you this build where I can see that the override starting message shows up now. So that build's running fine. So let's go back to my CI build. Again, I'm going to refresh. Remember, this was a miscellaneous, and there's no space here before, and this just didn't give us much information. So I'm going to refresh. When I do that, now I have my new category name, demo category, and when I click on ending message, it'll actually give me some information about that message, exactly the help message that I just submitted. So now all the customizations that I've done to my build play along really well, exactly like all the other arguments are set up throughout the entire build. So this looks just like it came from out of the box, and looks much more professional and much more. It's much more clear to the user as to what's happening. Not only can I set them here, but when I kick off my build, so if I go to Team Explorer and go to Builds, and I go to CI, and I'm going to queue this build, and I go to parameters. Now I can override those parameters here. So all the parameters that I just set, just like anything that comes out of the box, those can be set. So here's my demo category, my starting message and ending message. So all right, starting message during queue. So now I'll just override even further this starting message. So this value is going to be set only for the instance that I'm kicking off right now, as opposed to the one that gets set during the build definition. And you can do that with any other parameters, not just the ones that you create. So I'm going to queue this build, and let's go take a look at it. And here's my override starting message set during queue process. So I've just shown you how to do not only create a CI build, but also customize it so that you can take full advantage of the options that TFS gives you with the build template. Obviously, the samples that I showed you are very simple, given the time constraints, but you should be able to take that and create your own activities. There's some information out there in MSDN, how to create your own activities, add them to your templates, and really make the most out of the build process. Remember that using build and CI, it doesn't cost any extra if you're already using TFS. There was an earlier question about licensing. Once you get past that question, so once you have TFS, you have all the features that I just showed you are available with the TFS license. So you don't have to get something different or to be able to take advantage of all these things. So let me switch back over here. And I believe that we're getting close. So thank you guys very much for coming to this webinar. If anyone has any questions, feel free to email me at esteban.garcia@agilethought.com. Here's my blog, almguide.com, or you can also follow me on Twitter at estebanfgarcia. Remember, and obviously you can get lots of information about our company at www.agilethought.com. With that, thank you very much, and I'm passing the mic back to Jana.
Thank you, Esteban. I'm going to go ahead and request control here and put up the first of 3 poll questions. And if you wouldn't mind taking a moment to answer, we sure appreciate your feedback. And as a reminder, you may request a copy of the slides directly from our presenter today in the IM window, or make a request to him via his email address at AgileThought. And I'd like to thank Microsoft partner AgileThought and speaker Esteban Garcia for their presentation today. AgileThought presents Continuous Integration with TFS. And with that, ladies and gentlemen, this concludes today's online meeting. Thank you for joining us, and once you finish the poll, you may now disconnect. Thanks.